In this class, we are going to discuss about the analysis procedure of asynchronous sequential circuits. Okay, so already we discussed about the analysis procedure of synchronous sequential circuit and like design procedure of synchronous sequential circuits, right? So you know how to do that analysis procedure, like combinational circuit of analysis procedure or sequential circuit of analysis procedure. Already we know that is nothing but directly they given one logic diagram, or directly they given the boolean function, or maybe directly they given the one statement. Based on that we'll find out the first step, we'll find out the first boolean equations, then we'll go for the state table or transition table or whatever that state diagram. Okay, so that is a procedure, right? That means we need to first find out the boolean equation. The second step, we need to find out the characteristic table, or maybe we are calling like state table. Generally we are calling like truth table, right? So based on that boolean function we will find out the truth table, then we'll go for the state diagram, or maybe state diagram, or maybe logic diagram. So that is the general procedure for analysis of sequential circuit, or maybe combinational circuit, or maybe synchronous sequential circuit. Okay, so like this way here also analysis procedure of asynchronous sequential circuit having some steps. Okay, so how to solve a problem in how to solve a asynchronous sequential circuit in an analysis procedure means these are the steps we need to follow here. The first step is nothing but determine the secondary state and output equations from the given circuit. So that is nothing but directly they given one logic circuit. Based on that logic circuit you will find out the first output equations, that is we are calling like boolean equations. Okay, so now coming to the what is the second step, construct the state table. So you know in general name state table of another name is nothing but we are calling like truth table. So truth table is nothing but based on output equation we are finding the result, right? So here that means the relation between the input and output we are getting the truth table. So state table is nothing but how to find that state table, the relation between the present state and next state, that is called as state table. So now third step is nothing but we'll go for the construct of transition table. Okay, so how to do this transition table means I will explain this one. So and the next one is nothing but construct the output map. Output map is nothing but we are doing here k map. Okay, so now coming to the step 5 is nothing but construct the flow table. Okay, so already knows how to make the state table, that is nothing but write the input and output relation, and output map already knows. So the different names is nothing but transition table and flow table. I will explain this one in with respect to problem. So that is nothing but we are taking one example problem, then we will solve that by using these steps. You can easily identify what is the analysis procedure of any of asynchronous sequential circuit. Okay, so first we'll go for the one example. So that is nothing but here this analysis procedure of asynchronous sequential circuit consists of maybe obtaining a table, or maybe obtaining a diagram that describes the sequence of internal states and outputs as a function of changes in the input variables. So that is we are calling like here boolean equation. Okay, so now we'll see that what are the steps we are having. So this is our example problem. So just observe it, directly they given one logic circuit of asynchronous sequential circuit. Okay, so first what is the step? First step, determine the secondary state and output equations from the given circuit. So that is nothing but simply we can write it here. The first step is nothing but output equations are nothing but that is equal to the boolean equations. Okay, now find it boolean equations for this. So already they given here input variables and secondary variables and output variables. So now once see what is the input variable here means this diagram clearly shows the two feedback loops. Just observe here where we are having that feedback loops. So this is one of the feedback loop and this is another feedback loop. Okay, you know what is meant by feedback loop. So already we discussed in asynchronous sequential circuit of block diagram. So feedback is nothing but the output should be connected to the input. Okay, the output is again connected back to the input, that is called as the feedback. So just observe here, this output is again back to the input, no? So here also this output is again back to the input. So that's why this diagram having the, that means this logic circuit having the two feedback loops from the OR gate, and these outputs are back to the AND gate of inputs. Sorry, here. Okay, AND gate of inputs. Just observe here, this output of, that means OR gate outputs back to the AND gates inputs of first and second AND gate. Okay, so generally the circuit consists of one input variable that is represented like X. Okay, so and coming to the coming to this internal state, that is nothing but it consists of two internal states. That internal states have two excitation variables that will be represented like y1 and y2, that is in capital letters. Okay, so these are all also we can call it as like excitation variables. Okay, so and next, and it is also having the two secondary variables that is represented like y1 and y2. Okay, you know from the block diagram we have the internal states will be represented like small y1 y2, and excitation variables will be represented like internal state, that is nothing but capital letters. Okay, and the input variables we can represent like small x1 x2, right? So these are nothing but input variables and secondary variables, excitation variables. Okay, and coming to the delay, so that is nothing but if feedback is present means compulsory delay will be there in that, right? So feedback will be presented in that, that means we are having delay elements here. That delay is associated with each feedback loop. This delay, where we are connecting the delay, actually at feedback loop we are connecting, right? So the delay is associated with each feedback loop is obtained from the propagation delay between each y input and its corresponding output. Okay, so this is nothing but delay working circuit principle. So that is nothing but generally what are the inputs we are having for the circuit means these are the inputs and outputs we are choosing. Okay, so now we'll go for the analysis procedure. We will implement this circuit in analysis procedure. So what is the first step? We need to determine the secondary state and output equation. So first we'll write the output equations. So that output equations are, so how to write the output equations? That is nothing but we are having the internal states that will be represented like y1 and y2, right? So y1 is nothing but it will be connected like two AND gates with OR gate, right? So first of all we will find out the AND gate outputs, then we'll go with the OR gate output. So this first AND gate will be connected the one input variable x and one secondary variable y1. So that is nothing but this is in AND gate, will have the dot product, so x y1. So coming to here, this x will be complemented with the second AND gate, so then we'll get here x complement. So and this is having the y2, so in between we'll have the AND gate, the dot product is will be there, so then we'll get x complement y2. Okay, so now another third AND gate we are having, so that is nothing but the first one will be connected to the input of x, and the second one will be of second input of AND gate is nothing but that will be connected with y1 here. So but it is having up to this y1 this one, but it will be having complement, so then we'll get the y1 complemented here. Okay, so AND is nothing but multiplication, so x y1 complement. Okay, so finally we are getting the AND gate results. So now we'll find out the OR gate results for this. Okay, so first OR gate result is nothing but combining of first two AND gates. So OR gate is nothing but will have the addition operation. So the first input is nothing but x y1 and second input is nothing but x y2, x complement y2. So but in between which operation we are having? OR operation. OR is nothing but addition. OR gate we are having means addition. So x complement y2. So that is the final result for the y1. So then we'll get y1 equation is x y1 plus x complement y2. Okay, so now coming to write the second equation. So y2 is nothing but adding of these two AND gates result. So one is x complement y2 and we'll have the OR gate, that is addition. So and the another input is nothing but x y1 complement. So then write it y2 equation here, that is nothing but x complement y2 plus x y1 complement. So finally the step 1 is completed. Okay, so we are getting the equations here. X y1 plus y1 equation is equals to x y1 plus x complement y2, and y2 is nothing but x complement y2 plus x y1 complement. Okay, so this is the first step, that is nothing but step 1 is completed here. Now coming to the second step, what is the next procedure for the analysis of asynchronous sequential circuit means construct the state table. Okay, so now we'll take the another paper here. So we'll simplify the step 2, that is nothing but state table. So what is meant by state table generally? That is nothing but we need to write the relation between present state values as well as next state values. So I can represent it here. This is the present state, I can choose it, and this is the next state.